So how do we actually solve for coexistence? How do we actually solve for phase equilibrium using fugacity equals pressure exp of 1 over RT integral 0 to the pressure? How do we use this complicated equation to get what we actually want? And then to use it in models and simulations and design of reactors or whatever you're going to be doing with your careers. So we could do this if we had an equation for V as a function of T and P. We want V as a function of T and P. But as we talked about earlier, this is not so easy because this is not trivial. It's a cubic equation, and cubic equations are a pain to solve. At minimum, it's a cubic equation. It could be more. But there is a trick, thanks to chain rule, that makes this more accessible. So question, how do we get a solvable system? Okay, well, consider that if you have a product of two things, dPV, okay, and you're going to take the derivative of that, then you have V dP plus P dV by chain rule. Now, let's multiply both sides by 1 over V. Okay, so we have 1 over V under bar. The derivative of the product of those two is equal to dP, okay, plus P over V under bar, dV under bar. Or, just rearranging this gives us dP equals 1 over V under bar dPV minus P over V under bar dV. Okay, great. So now we can do a small trick, and then it's kind of cool. So dP is equal to P over P RT over RT, 1 times 1 over V under bar d of the product of PV, okay, minus P over V under bar dV under bar. So what we can do is, because we have pressure and volume related, we're just going to do a little bit of rearranging of this side of the equation and rewrite this as dP equals P over P times RT over V under bar d of PV over RT. Remember, T is a constant here, so we can do this. Minus P over V under bar dV under bar. Recall that Z is defined as PV over RT, and we calculated the Z at the critical critical point for some materials. For instance, van der Waals was equal to 3/8. Okay, so we can rewrite this equation as dP equals P over Z dZ minus P over V under bar dV. What good does this do? If you make the substitution and put this all back in to our dP term, in the integral equation, we have log of V for the fugacity coefficient is now equal to 1 over RT. Integral from pressure equals 0 is now a corresponding point of volume equals infinity. Volume has to infinity is the same exact thing as pressure going to 0. V of RT over V under bar minus P. Okay, it's great so far. dV under bar minus log of Z plus Z minus 1. Okay, look at this now. This is fantastic. Why? Because we have P as a function of V. This could be van der Waals, this could be Peng-Robinson. These are actual functions. Before, when we had it the other way, these were not actual functions. So once we have it in this form, we can actually solve for the fugacity coefficients by working it through this process of changing the variables on the integral. Now, it might not look simpler, but in fact, this really is simpler. This really does become something that's much easier to code. So it looks scary. It does. But this is actually easier. You know, this is kind of like, you know, I don't know, Beauty and the Beast or something, where the Beast looks really scary, but actually the Beast here, this fugacity coefficient, is a real nice function. Yes, the fugacity is a bit like the Beast. So, calculating the fugacity from an EOS, we can start with log FV over P equals, we just have to make some substitutions. You substitute in to your equation how you calculate the fugacity in these terms. The equations do get more complicated. So this could be log, if you substitute in not the Peng-Robinson, the van der Waals. This becomes log V over V bar under bar minus B minus A over RT V under bar plus PV over RT minus 1 minus ln of PV over RT. So, yeah, don't let all these logs and these equations scare you. We're going to give you, for your problem solving, the form of the fugacity calculation in terms of the substituted equation of state. Know enough, it's easy enough to just do on your own with some algebra. So the most important takeaway from this is that this equation is not scary, and that this is a very easily codable and calculatable quantity that we will use in a very short project to calculate the coexistence curves.